The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, I see we have a viewer suggestion today.
Yes, do you remember when I started the show about a year ago?
Oh yeah, like on your second day we made you do that horrible accent.
We'll be having this here one now then.
Yeah, Cockney, super easy, right, Ben?
Oh yeah, no problem.
So someone asked for us to make a set of adaptive headphones. So essentially they want to be able to listen to their music on a high-end set of headphones, but still be able to hear their kids in the next room.
Oh, like a baby monitor, but
Yeah.
for headphones.
Yeah.
Okay, how about this? Yeah, we'll get an off-the-shelf baby monitor.
Okay.
We'll have the music device, like an iPod or a phone. It'll go into the baby monitor, and then it will go out to the headphones. So we could have an in and output jack on it.
Nice.
And we'll make it when the baby noise threshold goes past a certain limit, it switches from music to the baby sound, and then we can make it stay on the baby for like 4 to 5 seconds. And then if the baby stops making noise, it'll switch back to the music.
Nice.
And I think we can do it with just integrated circuits, discrete components.
Cool.
Building it into the case. Cool, well, let's find a baby monitor and get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, like I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
If someone gives you 10,000 to 1 odds on anything, you take it.
Hey, look through the battery port, you can see there's like programming headers. See those pads there? Interesting. All right. There's probably not going to be very much to this. What I'd like to do is build the circuitry inside of this, because see, this has a really fashionable belt clip. In case you want to go to a rooftop party and like still hear your baby. I can't even imagine a time before the Nintendo Switch. Okay, this is pretty much all she wrote. Well, there's a lot of exposed pads, that's good. So this is gonna be your radio module right here. This is your cheap glop top integrated circuit that runs everything. Power regulator, crystal that runs the circuitry, got some caps, antenna right there, and only one IC really. I wonder what that does. It might be some sort of memory or identification chip. So my thought is we can use the batteries that power this to also power our switching circuit, kind of like the Nintendo Switch, but with less rooftop parties. Ding, 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 ding. All right, let's see what we got here. Are you a millionaire millennial, a millennial? Then you need the Nintendo Switch. Yeah, there's not much to this. There's a couple buttons and then the speaker connector there. So what I was thinking we could do is we could remove the speaker entirely and turn it into a headphone jack. Although the amplification that is going to it, we probably have to knock that down a little bit. Otherwise, it'll blow your ears out. You know what we can do actually? We can put some batteries in it and then see how much current it draws. Okay, it's drawing about 50 milliamps, which actually isn't too bad. Hey Felix, can you go in the other room and like be a baby again?
Looks like I need to empty the garbage.
Make a lot of noise.
I'm making a lot of noise now. I'm making so much noise. This is a lot of noise that I'm making. All this noise is a lot. Sure is a lot of this noise. I'm gonna find something.
So one thing I noticed was the LED indicators here, they act as kind of like a graphic equalizer. So I'm wondering if we could almost use those to trigger the threshold. I mean, that would be like the easiest way to do it. I mean, it's kind of a hack mod, but if it's already there, don't rebuild it. Okay, for our Rockin' Baby Monitor project, I got the ADG 436 integrated circuit. Now this is basically a 2-channel switching circuit, so we can use a logic on or off to switch from this channel to that channel. So I have the outputs hooked up to these headphones here. And this is what the person will be wearing. And then we have 2 sets of inputs. We have one hooked up to this Game Boy, another one hooked up to this Game Boy. And the default will be this Game Boy. We have a pull down resistor, so both of the inputs will be set to low, which will be this one. But if we push the button, it'll pull it high and switch the inputs. So let's just see if this circuit works. Okay, I'm gonna give it just maybe 2.5 volts. So that would be like 2 AAs that have run down a little bit. Let's turn on the Game Boys. All right, let's get some music going. Okay, so right now, I'm hearing the music from the Tetris Game Boy. Now the other Game Boy has Super Mario Land, Okay, so if I push this button, it should switch the inputs. I can hear both at the same time. So right now we're controlling it with a push button switch. The next step is to control it with some sort of external trigger. I'm thinking an op amp. So if this represents the baby monitor, most of the time it's not doing anything. But when a sound does come through it, we want to trigger it using the audio levels into switching to the secondary device. So now the question is, how do I combine this switching circuit with the baby monitor? So the switching circuit we did test, it works down to about 1.8 volts. But I think 3 volts, as in 2 AAAs, will probably be enough. So I'm thinking we might remove the speaker that's on here. So I'm just gonna mark the polarity. I don't know if it really matters, but I'll just mark it anyway. Oh, these are labeled as test points, not headers. So what they do is they design something with all the proper resistors and capacitors, and then they remove as many as possible until it stops working. Ah, modern electronics. So this was never meant to have a headphone jack, so I guess that's the first thing we should figure out. How do we get a headphone jack out of this? Or how do we mix the speaker audio into a headphone jack without making someone go deaf or blowing up the headphone jack? I'm gonna hook this up to my power supply and give it 3 volts, and then we can probe around and see where all the voltages are. My next task was to find the best place to get voltage on this baby monitor, so I could use that to power the switching circuit. While doing this, I found a boost regulator. This is used to boost the lower level of the batteries up to a stable level of 3.2 volts for device operation. I also discovered that this system voltage can be found on many test pads around the unit, as well as the positive terminals of several of the electrolytic capacitors. Next, I used my bench power supply to simulate the batteries losing charge. I discovered that the system kept working down to around 2.3 volts of battery level, at which point it stopped outputting 3.2 volts and stopped functioning. I hooked the speaker output up to this oscilloscope so I can see the waveforms from my voice. So when nothing's going on, we see a straight line. And when I talk, I can see waveforms. Blah, blah, blah. So I'm thinking we could do this one of 2 ways. We could do it like the talking puppet episode, where we use an op amp to detect any sort of high amount of oscillation coming off of the speaker. And then if we see that, we cause a trigger event which turns it on. Or we could possibly use these LEDs in front here because they already are based off volume. See? So what I'm going to do first is see if I can safely connect the speaker output to the headphones without blowing my ears out. And then if that works, we'll move on. I've hooked up a voltage divider and a capacitor to the speaker output, and I'm putting it into the headphones. That reduces the noise and the distortion that we hear on the speaker. So the speaker quality on this wasn't really that great to begin with. This system does not turn on or off if there's sound. It's basically always running. So there's a lot of basically noise floor static that you can hear. So what I want to do is I want to make it sound as good as it can on the headphones. Right now I just have it hooked up to one of the earphones. I'll hook it up to the other as well. But I think what I can do is I can pass through 2 voltage dividers and 2 capacitors so I can actually make this go into stereo. And I'm still thinking that what I might do is use the indicator lights here to actually trigger the level. The challenge with that is, these are quite binary, like you either hit a level or you don't. So what I could try to do is maybe have a setting where you select which one of these indicator lights will actually trigger your audio to switch. I think I'm going to shrink this part of the circuit down onto the board to make it as small as possible to make sure I have good audio coming off of the original speaker amplifier circuit, and then if that works, we'll continue on. So I took another one of the ADG436 chips and I soldered it directly to the board. I have the grounds connected to one of the capacitors, so we have a nice solid connection there. And then the 3.2 volts that we found coming off the boost regulator, I have that connected to the power of the chip. What I'm going to do first is connect the interrupt input. So on the Game Boy, it was this one. I'm going to connect it to the voltage divider and capacitor that we have coming off the speaker circuit. And then once I have that done, I can connect connect wires from here to a headphone jack, and that will be the iPhone or music input. We have one connector going to 2 pins because it's mono going to stereo. So I'm going to take this piece of wire here, and I'm actually just going to strip it back a little bit, like so, and then I'm going to bend it around. So see, now we have a contiguous piece of wire that has 2 ends on it. Because if we tried to connect 2 separate wires to a small point like this, the molten solder would cause them to, fall around and bend. But with this, it will stay put. All right, so I have the first point hooked up. So let's see, we go to 4 up on the right. So I'm gonna bring this one down and under. Now I have to keep in mind that the battery pack is back here, so I have to make sure everything's on the side so it doesn't hit the battery pack on the inside of the case. So this wire, I'm gonna bring it under the power wire just so it's, nice and neat. There won't be any surprises later on. And the other one connects to 4 down on that side. There we go. All right, so that is the baby monitor output going into the switcher chip. I'm gonna put in one of the headphone jacks, I think. Yeah, I'm just gonna eyeball it. Can you tell us about the time you were in the war? I don't like to talk about it. You got blinders on to the world, warhorse. This is the way the world works now. Bombs, tanks, guns. So I'm gonna hook this up using the minimum distance that I can, kind of like that. Then we can see if it's switching properly. I think one challenge we might have is we might be able to trigger the switch by using the indicator lights, but the thing is, it'll only be switched while the light is on. We might still need to add a 555 timer, so it's like, oh, if we hit that volume level, then I'm gonna switch over for a minimum of, 3 seconds or something. But we'll test it one thing at a time. I've got the input jack and the output jack both wired up to the switching circuit. I don't have the input control in the switching circuit attached to anything yet, just trying to get everything else done. I've also added some longer power wires for the batteries because the old ones weren't quite long enough. But I want to make sure everything on this circuit kind of folds open like a book in the same direction. And then anyway, once I have this stuff all done, then I will test the switching circuit just using one of those LEDs on the front. That's not the best way to do it, but again, I just want to test to make sure everything's working correctly at the moment before I go in and make things more complicated. So yeah, we should be able to do a test here pretty soon. In the other room, we have the baby monitor listening to some video game music. And in here, we have it hooked up to a Game Boy. So the Game Boy is simulating, like your music player or whatever. So if the select pin is high, we hear the Game Boy. And if it's low, we hear what's over the baby monitor, which in this case is Mega Man music. So Game Boy, baby. So the Mega Man music represents the baby. All right, so it's switching correctly between the inputs. Now what we need to do is set it so it switches automatically. So I have the switching circuit built. Basically, by default, it plays the input channel, which would be like your music, or a Game Boy in this case. And then if sound comes over the baby monitor, or if you switch the integrated circuit to to the other channel. Basically, this is your control. If you have it at 0, logic low, it will play the music device. If you bring it high, it will switch to the baby monitor. And we know we can use these LEDs to detect, voice or crying, but we want it to actually latch on and stay that way for a few seconds. So even if there's a brief pulse of a loud sound, we want to use a 555 timer to make sure that the unit stays switched over for a minimum amount of time. So that way, otherwise it would be switching back and forth. You'd only hear it when it peaked a certain amount. So now I want to make it so when it peaks, it latches on for 5 seconds. So we can do that with a 555 integrated circuit timer and some capacitors. I cut the leads off of the 555 timer to make it smaller. I didn't have any surface mount versions of it. And I'm attaching it directly to the power, and then there's a ground pin here, because on the 555, power and ground are at the top. And then what I'm gonna do is attach some, small, hopefully surface mount capacitors around it. So we want the 555 to be triggered by the LED indicator, and then it will stay on. It will keep our signal line high for, I'm gonna say 4 seconds. That's probably good. Because what if the baby just burps? I mean, who cares? I mean, maybe mothers and fathers care about that. But if something insignificant happens, it's just like, quick 4 seconds, then back to the music. But if the baby continues to cry, it'll like re-trigger and you'll stay on the baby channel until you're like, fine, I'll go change the diaper fluid. Diaper It looks like your diaper fluid is low. Here's what I did. I wired up a 555 timer in monostable mode, also called one-shot mode. When these indicator LEDs are turned on, what's actually happening is that they're being sourced with 2.6 volts, and then the microcontroller pulls the other side of them low, allowing them to turn on, allowing current to flow through the resistor. So normally it's high, and then when it's active, it's low, the LED I mean. So what I did was I took that and hooked it up to the input, or the trigger, of the 555. So whenever there's a falling edge on the 555, the one-shot triggers for a specific amount of time. And that amount of time is controlled by this resistor and this capacitor. It's about 4 seconds. So instead of just having it switch over to the baby only when there's sound, which would be kind of like, like going back and forth. When the baby makes a noise, it'll turn on for about 4 seconds and then switch back. So that should be a little bit more consistent. All right, let's test it out. I'm gonna put a battery in here to turn on the parental unit. Input, we're gonna use the Game Boy to simulate, the cool iPod music or whatever it would be. So the speaker is the output of the device. So right now, the baby's not making any noise, so we're hearing the Game Boy. Hey, Max, can you be a baby? All right, be a baby again. Now stop. 1,002, 1,003, 1,004, 1,005. Okay, so it's about 4.5 seconds. All right, we've set it up. Karen is in the other room complaining about Russell Crowe's performance and Les Miserables. So we're going to listen in. So I've got this music here. So I guess I could listen to the soundtrack and listen to Karen when she complains about Russell Crowe. So we're going to go from the iPod into the baby monitor out to, we'll use a speaker in this case. So I'm sitting in here. Gee, I sure hope no one complains about Russell Crowe.
They could have hired any other actor, like possibly one that performed on Broadway with an actual good singing voice to play Javert, but no, they had to hire an actor that didn't have the range to sing his last song, so in his final cathartic moment, they had to lower it a whole freaking octave, and it wasn't any good, and at least he jumps off the cliff into the fountain thing and dies when he hits the water or drowns or whatever, man.
Wow, that's like a film critic, baby. So yeah, it works pretty good. So let's say I'm a mom or a dad or whoever. So yeah, I'm gonna do some household things. Perhaps I'm gonna clean the fireplace or something. I'm cleaning the fireplace. I sure hope my baby... The baby's talking.
Peter is Luke's father.
This baby's got lots of spoilers.
Bruce Willis is really dead.
I hope she doesn't give away the end of the crying game.
People cry about a game.
Well, that's all the time we have for today. Karen, how do you feel the rockin' baby monitor turned out?
I think it turned out great. It does everything we wanted it to do, and you're able to reuse the original case. It's nice and small and portable.
Right.
I think we got a win here.
Yeah, this is a good example of a project where you can just add a few integrated circuits to an existing product and make it do something completely different.
So is there anything you would have done differently with this project?
Yeah, I'd prefer if the headphone jacks were on the bottom. That'd be more convenient, but there
Yeah.
wasn't any room for them down there. Also, this knob is a little big, but it was the best choice that we had.
Yeah,
the
I think
mixing
it's good.
knob.
So we made this project to make life a little bit easier for parents. What other devices could we build to make your life better as a parent? Let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time, or maybe we'll hear you. I'm a baby.
Gwyneth Paltrow has a flame-proof bra?
Oh, sorry. For some reason, we couldn't build enough of the Nintendo Switch. I guess it's on back order. The Wii sold out immediately last Christmas, but we didn't anticipate the demand 2 Christmases in a row. Your baby brother is mine forever.
You do a lot of rapper stuff today. She was like, it's on fleek when my skateboard.
Genesis is Planet Forbidden.
Ben, why are you constantly trying to enrage me?
Master has given Dobby clothes.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.